Welcome to day 15 of the macOS and iOS Security Internals Advent Calendar. Today we will have a look at kernel panic dumps. XNew supports so-called remote panic dumps. Apple has them very well documented in a technical note TN 2118 called kernel core dump. And this is basically really what it is. It's a remote core dump of the kernel and the kernel address space over the network to a server that receives all the data and basically writes a macOS file to disk that contains all the kernel state and the kernel memory basically. And this can then be loaded into a debugger or tools like IDA or other kind of disassemblers that understand macOS files. The way this works is that you have to activate it via boot arguments, namely these boot arguments that you can see here on the slide. The trick here is that of course you need to disable zip again, otherwise this will not work. So the boot arguments you see here, debug is basically for activating this feature, and then you have to specify with the _panicd_IP where this is in the network, where is the panic server. For more complex network setups, you might want to specify the router IP. Because otherwise the panic dumps will just not receive, will not be received by the server, and then it will just reboot the system. You can theoretically specify the panicd port, but you can just use the default if you don't change it on the server side. And the same thing is true for the panicd core name. You don't need to change that, the default will be just fine. So now to the debug boot argument. What are the flags that you can set? Well, there are many flags. I just listed the most important ones here. So we want a remote kernel dump, for example, on a panic. So we need the 0x400 in the flags. You can also specify that you want to have a dump on an NMI. In this case, you need the 800 here, but the NMI is also another argument here that you would have to activate. An NMI is basically a special button combination that you can press, and then it would trigger the panic dump, basically. dbarp is for more complex network setups. It means it should not send just plain UDP packets, but it should also try to use ARP packets so that it works in more complex network setups, basically. But my recommendation is always use Ethernet connected devices in the same class C network without any router in between. That's usually the best setup, and this makes it most possible for working out of the box without any tweaking. So the kernel panic server comes as a launch daemon from Apple. Here you can see the plist for the launch daemon. It is basically com-apple kdumpd, and as you can see here in the launch daemon configuration files, it, for example, specifies where on the file system it tries to find the panic dumps directory. So this is where we'll write the panic dumps. This used to be just /panic dumps, but then Apple changes to var temp panic dumps. Again, you could theoretically change that, but if you want to change any of the configurations, what you need to do is you need to copy the plist file to a writable location, because this is under a zip protected directory. So you should have it in a different directory, and then you can just modify what you want and load the service from there. You can also specify here the port number, but then keep in mind you have to change it in the boot argument also. This year we'll use nobody with the umask 7. So you can theoretically also change the user here, but for now I just leave the defaults. So then the next thing you need to do is you need to actually create the directory on your panic log server or panic dump server. And I do this by just creating it as root. I make it root owned, and then I change mod it to a way that the nobody user can for sure write into it. And once you've done that, you can then just activate the launch daemon via launchctl. Don't forget to use sudo load -w and the daemon file. If you want to have a modified configuration, you would have to copy that somewhere else and specify this in the load. Aside from that, it would be exactly the same. So once you've done that, you would then have to configure the panic dump client, which is your victim basically. And you do that by setting the boot arguments. We set debug 0x440, which means ARP and kernel dump on panic. And we need to specify the panic D IP. Here it says 1234. Of course, that's not the real IP. You would have to put the IP of your server. So you need two systems for that. And then you just reboot the client and you need to trigger a kernel panic, however you want to do that. I will show you later on one way to do this basically via dtrace. So once you've done that and everything was set up correctly, what you should notice is that in your var temp panic dumps directory, there's a core file that keeps slowly growing. And this is something that takes a while. It really depends on your network setup and how fast both systems are and how much packet loss there maybe is. And just let it run, and at some point your client will likely reboot. That's one sign that it's finished. Otherwise, another sign is that this file is not growing anymore. But you just let it run for a while. It could be a while. And the size basically depends on how much memory of your target is already used because it needs to create a dump and send it over the network. So this dump can then be loaded into LLDB. And the way you need to do that is you need to first realize that on newer versions, the dump is automatically gzip compressed. So you would need to first ensure that the dump is usable by the nobody user, not by your user, because it's owned by nobody, as you see. So the first thing you should do is you need to change the ownership shift to your username. Yeah, there's like a little typo here on the slides. It should be that like your user here should be the owner of the core. So this core here is wrong. Also keep in mind you need to do it as the root user, so maybe sudo or broot at this point of time. And then once you've done that, you need to unzip this because otherwise LLDB cannot understand it. And once you've done that, you can then attach LLDB-C like normal core dump, and you just specify the name of the core dump, and you are then attached with LLDB. So much talking. Let's show you this in an actual real setup. Okay, now let me show you the panic dumping in a real setup. So you can see here I'm already in my panic dumps directory, and I can show you the path name is var temp panic dumps, and I already tested this earlier, so you can see there is already a panic dump inside here, but we will not be using this. We will try to create our new ones. So we then need to do and find out what is the IP of this here. So let's find out what the IP is. And our IP is 192.168.50.94. So now this is our server, and it has the kdumd already running. So I already did this with sudo launch ctl and so on. So now I'm in the victim. So as you can see here, this is our victim, and the victim already has a boot args set. So let's say nvram boot args. You can see that boot args is debugs 0x440, and the panic DIP is 192.168.15.94, which is our server's IP. And I had already rebooted everything, so everything should be fine. But now the big question is, how can we actually cause a kernel panic so that a dump will happen? So the easiest way to do this is actually by using dtrace. So we can use sudo dtrace -w-n and then begin and call the panic function. And when we run this, yeah, of course, we have to enter our root password. And what happens now is it should start crashing and start creating the dump. Sometimes this takes a while, so let's have a look here. I now hear the fan spinning up. So let's see what happened. Here has nothing happened yet. So let's see if it takes a while for this to work. It's still not doing anything. Oh, there you see. It's now starting to create the second file. This one here. And you can see it slowly grows, and you have an idea from the other file how big the file will eventually get, and you see how slow this actually will be. So meanwhile, the core dump server has stopped recording, and what we can see here is this time the new core dump is actually quite a little larger than the first one. Not really sure if the first one was maybe truncated or what's so different that it's now zipping it a lot worse, you can see. Okay, let's work on it now. So as I told you, we need to first make sure that we can access it. So let's unzip the new one. And now we can make it owned by our user. And this should now work. And now we can do an LLDB-C on this one here and see what happens.